Alrighty, gang, I'm going to show you how Gibbs energy changes with pressure, so the pressure variance of Gibbs energy, and I'm going to show you that using a very common exam problem right here. We want to determine the change in Gibbs energy. This is the change in molar Gibbs energy for the isothermal constant temperature compression. This also works for expansion of a perfect or ideal gas from 1 to 5 bar at 100 degrees Celsius. So to determine this, we're going to start off with the fundamental equation of chemical thermodynamics for a closed system. This is in differential form. dg, G is our Gibbs energy, equals V times dP minus S. S is entropy, not enthalpy, times dt. Now, this is a constant temperature process, so dt equals 0. And to get delta G, we integrate this equation, so we'll integrate both sides right here. Now, the integral of dg is G from initial to final, so this becomes delta G. Now, we need to integrate with respect to P, but we have a V here that also changes, so we're going to use the perfect gas law, PV equals nRT. We're going to solve for V and substitute it into here, which is what we have here, delta G on the left, and then nRT over V, which is what or over P, which is what V is. Now, this we can integrate. N, R, and T are all constant, so they get yanked out of the integral. We now have the integral of 1 over P, which is ln P. So we can evaluate the integral right here. Remember our limits of integration. And at this point, we can plug things in, although there's a very subtle notation point that I should make that's very important. This is delta G. So this is the absolute change in Gibbs energy. We want the molar, the change in molar Gibbs energy. So to do that, we need to divide this side by N, divided by the number of moles, amount of moles. So if we do that and plug in our numbers, we get the change in molar Gibbs energy. Even though we're dividing by N, this becomes an M. M stands for molar. We want to use the R that has joules in. Temperature is always in Kelvin. And then pressure can be whatever units as long as they cancel. If we plug that into our calculator, we get a change in molar Gibbs energy of plus 4,991 joules per mole. We usually convert this into kilojoules. And my friends, that's how Gibbs energy changes with pressure using a kind of a common exam problem here. Good luck on your midterms, final exams. Hang in there. Thermal's not an easy subject, but the more you do, the better you'll get. Cheers.